mathematics is fun and exciting.
Mathematics is a universal language.
Mathematics help us understand the world better.
Mathematics is useful in everyday life.
Mathematics offers rationality to our thoughts.
Seen again and again in the natural world, from spiral galaxies to spiral bacteria, from the packaging of atomic particles to the packaging of grape clusters, from the meandering contours of sand dune and brain corals to the explosion of ice crystals and flower petals, and in the branching of lightning and tree limbs. Patterns are ever present in the world around us. It is a natural occurrence, a man-made design, or an abstract concept. As a result, a pattern's elements repeat in a predictable manner. Patterns have a mathematical structure beneath them. Indeed, mathematics can be viewed as the search for regularities, and any function's output is a mathematical pattern. Theories in the sciences describe and anticipate regularities in the world in a similar way. The Fibonacci sequence and the golden ratio are expressed in the number of flowers' petals and among other things. In nature, visual patterns are frequently unpredictable, rarely exactly repeating, and frequently involve fractals. Natural patterns include spirals, meanders, waves, foams, tilings, cracks, and those created by symmetries of rotation and reflection. Decorations or visual motifs can be mixed and repeated in art and architecture to create patterns that are intended to have a direct impact on the beholder. Moreover, decorative and structural components such as columns, pediments, and lintels can be used and repeated by architects. A software design pattern is a well-known solution to a range of programming challenges in the field of computer science. In fashion, a pattern is a template that can be used to make a vast number of identical garments. Symmetry in everyday language refers to a sense of a harmonious and beautiful portion and balance. A shape or an object has a symmetry if it can be divided in two or more identical pieces. Symmetry in mathematics refers to the fact that whether one shape is moved, rotated, or flipped, the other shape remains identical. We call anything asymmetrical if it doesn't have symmetry. In geometry, the idea of symmetry is widely used. Mathematical symmetry can be observed in relation to time, as a special relationship, through geometrical transformations, through various types of functional transformations, and as a feature of abstracting such as theoretic models, language, and music. In general, every kind of structure in mathematics will have its own kind of symmetry. Examples include even and odd functions in calculus, symmetric groups in abstract algebra, symmetric matrices in linear algebra, and Galois group in Galois theory. In statistics, symmetry also manifests as symmetric probability distributions, and as keenness, the asymmetry of distributions.
Modern society simply could not exist without measurement. 21st century civilization is inconceivable without the indispensable measurement on which everyday life depends. Time, size, distance, speed, direction, weight, volume, temperature, pressure, force, sound, light, and energy are among the physical properties for which every humans have developed accurate measures, without which we could not live our normal daily lives. Measurement is the qualification of attributes of an object or event, which can be used to compare with other objects or events. Moreover, it is defined as the process of comparison of an unknown quantity with a known or standard quantity. Measurements can have multiple levels, which would include nominal, ordinal, interval, and ratio scales. On a baseline level, measurements fall into categories of weight, area, volume, length, and even temperature. While we look at these various categories as stoic form of mathematical measurements, a closer examination of things we do in everyday life reveals their clear importance. Playing sports, keeping yourself warm or cool, understanding weight, purchasing, and among others involve measurement. Furthermore, measurements provide a standard for everyday things and processes. In math, time can be defined as an ongoing and continuous sequence of events that occur in succession, from past through present and to the future. Time is used to quantify, measure, or compare the duration of events or the intervals between them, and even sequence events. It is familiar to everyone ever since humans first noticed the regular movement of the sun and stars. We have wondered about the passage of time, yet it's hard to define and understand. Science, philosophy, religion, and the arts have different definition of time, but the system of measuring it is relatively consistent. The early inventions such as oil lamps, water clocks, sundials, candle clocks, mechanical clocks, and others were made to easily divide the day or the night into different periods in order to regulate work or ritual. So the length of the time periods varied greatly from place to place and from one culture to another. We measure time in seconds, minutes, hours, days, weeks, months, and years with clocks and calendars. These instruments can be anything that exhibits two basic components. 1. Regular, constant, or repetitive action to mark of equal increments of time. And 2. A means of keeping track of the increments of time and of displaying the results.
Estimation. As you walk around and live your life, imagine if you could easily estimate how much a bill will be, which item is the best value for money, the size, areas, and angles of things. Estimation is finding a number that is close enough to the right answer. Hence, this often is obtained by rounding off the numbers involved in the calculation and getting a quick and rough answer. Additionally, estimation can also be done by sampling, which is counting a small number of examples something and projecting that number onto a larger population. For instance, we'll be determining how many candies of a given size are in a glass jar. Estimation in project planning can be particularly significant because plans for the distribution of labor and for purchases of raw materials must be made, despite the inability to know every possible problem that may come up. Furthermore, estimation is important in business and economics because too many variables exist to figure out how large-scale activities will be developed. In making an estimate, the goal is often most useful to generate a range of possible outcomes that are precise enough to be useful, but not so precise that is likely to be inaccurate. Money. Money is something that people use every day. We earn it and spend it, but don't often think much about it. Money is a commodity accepted by general consent as a medium of economic exchange. It is the medium in which prices and values are expressed. It circulates from person to person and country to country, facilitating trade, and it is the principal measure of wealth. The money supply of a country consists of currency, banknotes, and coins, and depending on the particular definition used, one or more types of bank money, the balances held in checking accounts, savings accounts, and other types of bank accounts. Money can buy you your needs and wants, peace of mind perhaps, or great comfort. With money, people can fulfill their material needs. However, money cannot buy everything such as happiness, friendship, and love, health, and appetite. To summarize, money has taken many forms through the ages, but money consistently has three functions: store of value, unit of account, and medium of exchange. The use of money eliminates issues from the double coincidence of wants that can occur in bartering.
Geometry. One such element of math that can be found in almost every aspect of our world is geometry. Whether it's a man-made construction or an organic life form, geometric shapes, symmetry, and the golden rectangle have helped to shape the world around us. Geometry is the branch of mathematics concerned with the shape of individual objects, spatial relationships among various objects, and the properties of surrounding space. Geometry can be found among many things, from the six-fold symmetry of snowflakes and the splash of raindrops that cause radial symmetry to the bilateral symmetry on the faces of tigers or the wings of a butterfly. All the visually and spatially related concepts are categorized under geometry. There are three types of geometry and these are Euclidean, hyperbolic, and elliptical. Geometry can be used to calculate the size and shape of many things. For example, geometry can help find the surface area of a house, the volume of a box, or the area of a farm. Geometry has influenced how civilization have constructed buildings and stadiums. Just like in ancient Greece, the golden rectangle was used to build aesthetically pleasing buildings that look to be in perfect proportion. These are just few examples of geometry in the world around us. If you look at the things with a keen eye, you'll find examples of geometry in almost everything you see. Studying geometry makes us more aware of the world around us. We learn how and why things are constructed, and that in turn influences our own creations. Fractions. When you first learned fractions, you probably did not see a point in having to learn them. But did you know that fractions are so useful? You already use them in your everyday life. A fraction shows part of a wool. This wool can be a region or a collection. The word fraction is derived from the Latin word fractio, which means to break. The Egyptians, being the earliest civilization to study fractions, used fractions to resolve their mathematical problems, which included the division of food, supplies, and the absence of bullion currency. All fractions consist of a numerator and a denominator, and they are separated by a horizontal bar known as the fractional bar. In math, there are three major types of fractions. They are proper fractions, improper fractions, and mixed fractions. Mixed fractions can always be converted into a fraction. An improper fraction can be converted into a mixed fraction. Lastly, a mixed fraction is always greater than 1. Moreover, fractions are an indispensable part of our life, and without even realizing it, we constantly use fractions in our day-to-day tidings. Whether it is 1/2 a dozen bananas on your shopping list or baking a yummy chocolate cake with 3/4 cup of flour and 1/4 cup of milk, everything around us involves fractions. Thus, Don't forget that fractions, decimals, percentage, and ratios are all connected.
How likely something is to happen. Whenever we are unsure about the outcome of an event, we can talk about the probabilities of certain outcomes, how likely they are. The analysis of events governed by probability is called statistics. Many events cannot be predicted with total certainty. We can predict only the chance of an event to occur. Probability can range from 0 to 1, where 0 means the event to be an impossible one, and 1 indicates a certain event. Probability theory is applied in everyday life in risk assessments and modeling. The insurance industry and markets use actuarial science to determine prices and make trading decisions. Governments apply probabilistic methods in environmental regulation, entitlement analysis, and financial regulation. An example of the use of probability theory in equity trading is the effect of the perceived probability of any widespread Middle East conflict on oil prices, which has ripple effects on the economy as a whole. In addition to financial assessments, probability can be used to analyze trends in biology, in particular disease spread, as well as ecology, like biological Punnett squares. As with finance, risk assessment can be used as a statistical tool to calculate the likelihood of undesirable events occurring and can assist with implementing protocols to avoid encountering such circumstances. Moreover, probability is used to design games of chance so that casinos can make a guaranteed profit, yet provide payouts to players that are frequent enough to encourage continued play. In the technology-based society, where we need to be able to think critically about complex issues and analyze and think logically about new situations, devise unspecified solution procedures, and communicate their solution clearly and convincingly to others is a basic life skill and is essential to our day-to-day lives. The importance of problem solving in learning mathematics comes from the belief that mathematics is primarily about reasoning, not memorization. Problem solving allows individuals to develop understanding and explain the processes used to arrive at solutions rather than remembering and applying a set of procedures. It is through problem solving that individuals develop a deeper understanding of mathematical concepts, become more engaged, and appreciate the relevance and usefulness of mathematics. Moreover, problem solving in mathematics supports the development of the ability to think creatively, critically, and logically, the ability to structure and organize, and the ability to process information. In real life, there are a variety of board games that can improve critical thinking and problem-solving skills. When you play board games with others, you can improve your communication and teamwork skills. In addition, many computer games increase problem-solving skills and reaction times with time trials and challenges. Computer games can also help to develop multitasking skills as you need to complete minor tasks with the larger goal as the focus. Furthermore, financial crisis, examinations, and billings are among the examples of real-life problems in mathematics. Problem solving should underlie all aspects of mathematics teaching in order to give individuals the experience of the power of mathematics in the world around them. This method allows people to see problem solving as a vehicle to construct, evaluate, and refine their theories about mathematics and the theories of others. Mathematics, for most people, is a system which concerns with numbers and calculation. People find it boring and not worth the effort we invest on it, as it is just involves the working with numbers and calculators. However, mathematics is the most beautiful and most powerful creation of human spirit.